Okay, guys, now you do also need to know stuff for the trigonometry part of your Ad Maths exam. So you obviously, I hope you know SOHCAHTOA. You have to know that. That's basically, yeah, sine theta. So basically the sine is going to be opposite over hypotenuse. Cos is obviously going to be adjacent over your hypotenuse. And your tangent is going to be your opposite over adjacent. And as you all know, you can also rearrange this equation. So suppose you were to just flip it. So what you could do is you could rearrange it, and you'd find that in doing so you could divide sine by cos, and that would be, it would be opposite divided by hypotenuse divided by adjacent divided by hypotenuse, and then that would just flip because dividing fractions, so the hypotenuses would cancel out, and you'd get sine theta divided by cos theta is equal to opposite over adjacent. And do you know what else is opposite over adjacent? Tan theta. And that proves one of the identities. Sine theta divided by cos theta is equal to tan theta. You also have other stuff. For example, you can look at your area of your right-angled triangle, or just your right-angled triangle itself. And suppose you were to have a hypotenuse of 1. That would mean, and you have your angle here. So sine theta is equal to opposite over hypotenuse. Hypotenuse is 1, therefore the opposite is sine theta. So you get sine theta over here. And then you obviously the same for this adjacent side, because it would be adjacent over hypotenuse, which is 1, so you get cos theta. And then you can form the equation sine theta squared plus cos theta all squared is equal to 1. And that's another identity. And in notation form, we can simplify this without these brackets and everything. You can just say sine squared theta. That's just a notation where it doesn't mean you're doing sine twice, it just means you're squaring the answer. Plus cos squared theta, and then etc. So that is another identity you need to know. And when you use those two identities, you can solve loads of things, you can prove loads of things. And sometimes in the exam it might give you an identity, and you use that new identity along with those two identities you already have. Or you might be asked to prove a new identity using those two you already have. You then have other stuff like, I think you can have half. To find the area of any triangle, you just need half sine CAB. I'm just using random signs. Half AB sine C. That'll give you the area of any triangle. And you have your fundamentally important cosine and sine rules you need to know. You can use them together often, which is quite useful. So you have, I think the sine rules, yeah, sine. I think the capitals, I can't remember, I never get it right with those capital letters. I usually use theta, but sine A over A is equal to sine B over B. And it can be arranged any way you want, which will always come in use. That's the sine rule. You also need to know the cosine rule, so you can do the rearrangement as practice, but cos theta is equal to b squared plus c squared minus a squared over 2bc. You need to know that, but that's easy to remember. And also you just rearrange it so you get a squared is equal to b squared plus c squared minus 2bc cos c theta. Or actually it's cos a, isn't it? I think it's cos a. Yeah, if it's yeah, it is cos a. So that will just tell you that, but yeah, theta A, same thing. You do need to know other stuff as well, like the graphs. You need to know the graphs of those. So I think you can just get your usual exam calculator out, and if you were to do this, so what you do is you just do sine 0. What's that? 0. So at 0, sine is nothing. What about sine 90? Sine 90 is going to be 1. And obviously it's a wave, so 180 is going to be 0, and then 270 is minus 1. I'll just check that. Sine 270 minus 1, yeah. And then you just get your sine wave, which is like this. And it goes on for infinity. But normally we have the bounds of 360 and 0. And that is in degrees. Make sure your calculator is in degrees. If it was in radians, this would be 2 pi, or as some people like to call it, tau. But then you also have other stuff like your cosine graph, and that starts at up here at 1. At 90 it's 0, and it just goes like that, and that's your graph, and it just keeps on going on like a wave. I'll just check that. Cos 90 0, yep. And you can also remember that sine theta, it's one of those basic things we did long back, is cos 90 minus theta. And that's one way of remembering how that graph will always work. Even if it's greater or less than, it'll still, it'll tend to work. And that's just within that small range, it doesn't apply everywhere. Then you have your tangent graphs, which are more abstract, because they cover a much larger range. So if you were to have your usual graph, your tangent graph, it goes like this, and then like that, and then like that. And I think these intervals, you can just check on your calculator, they're 100 and the full wave is about 180, I think. So you can test tan 89 will give you a large number. Yeah, and if you were to do, you can just test stuff in your calculator. So tan 0 is 0, tan 89.999, it's going to give you a massive number, and then tan minus 89.999 is going to give you a very negative number. So these peaks are at the 90 mark, and these troughs are at also the 90 marks. The 0 point is going to be where you find your first 0. And there's that diagram we always have. It's a circle for some reason, just to say the angles we've got. A means all, they're all going to be positive in this region. And obviously, from a sine graph, you know that the sine is going to be positive in this region. You're going to have your tangent, because it varies by 180, and then your cos, because it's, if you go back 90, it'll still be positive. So that is your sort of circle you need to remember about what's positive, what's negative, making sure that those are all right. And then finally in the trigonometry section, you have 3D and stuff. But 3D is awesome. It's not as fun as working in 4D. 4D is just the best, but 3D is alright. So you have different shapes. Obviously different people call different dimensions, but X, Y, Z dimensions. So you never know, is this the positive or is this the positive? Because there is some controversy depending on the usage. But what you'll find is if you got to always visualize these shapes in 3D. It'll give you a shape, and then you've got to remember that you have planes, you have lines, and it might ask you to find the angle between a line and a plane. And that can be quite hard, especially in the diagram. So suppose you were to have a simple square, and you have a sort of a triangle like this up here, and you want to find this angle, the angle between this line and the square plane. Well, what we can do, let's use blue. What we know is we've got this. We need to find this line, because this line hits about this much over the plane. So you just find this point, and then you'd work out along the plane this angle between this line and this line. And make sure you don't do it on some other angle that is on the plane, because those angles won't be quite as accurate. For example, if I were to find a line here, it won't be the same plane that we're talking about, because here, when you're finding this angle, it is on this plane, and it's also on this line. But for example, this is not really the smallest angle you can get, because we're kind of taking up too much space, and this isn't quite the plane we need. So that helps you with 3D. Just try and get those lines correct, and remember, try and visualize it in the third dimension, which will help. That's all you need to know for trigonometry. Just get your sine, cosine, and tangent right, your cosine, sine rules right. Use them together. You have your ambiguous case of the sine rule because of it going over and stuff. So just watch out for that. And that's all you need to know for trigonometry.